Hey there, and welcome. Today, we're going to crack open the user manual for your brain. We're diving into something called information processing theory, which is really just a fancy way of understanding how your mind actually works. So, let's get into it.
So have you ever been there? You're introduced to someone, you shake their hand, and poof, their name just vanishes 2 seconds later. Or maybe you call for a phone number, and by the time you actually go to dial it, it's just completely gone. It happens to all of us, and it is seriously frustrating.
Well, the key to figuring that out is actually a pretty powerful analogy. The theory we're exploring today suggests that we should think about our minds less like some kind of mysterious black box and a lot more like a biological computer.
And look, this isn't just some cute metaphor. It's the whole foundation of information processing theory. It gives us a real framework, a model to understand how we take in information from the world, how we think about it, and how we store it for later.
So what is this theory exactly? Well, it's a way of looking at our brains that says we don't just, react to stuff. No, we're active information processing systems. We're constantly taking in data from our environment, we're analyzing it, and then we're making decisions about what to do with it.
And just like a computer, our whole mental workflow can be boiled down to 3 basic steps. You've got input, which is everything coming in from our senses. Then there's processing, which is where we actually think about it and make sense of it. And finally, output, which is how we respond or what we decide to store in our memory. So let's break that down, right? Starting with stage 1.
All right, so where does all this information start its journey? It begins right here, at what we can call the sensory front door. Researchers call it sensory memory, and it's the first point of contact for everything from the outside world. You can think of this as all of your computer's input devices running at the exact same time. Your eyes are the camera, your ears are the microphone, your skin is the touchscreen. It is constantly, and I mean constantly, gathering raw data from everything you see, hear, and feel. But here's the catch, and it's a big one. At any given moment, your sensory memory can only really hold on to about 4 distinct pieces of information. That is not a lot, especially when you think about the absolute fire hose of data that's hitting you every single second. And if that's not crazy enough, get this. That information, it only sticks around for, at most, 3 seconds. A half second to 3 seconds. If you don't do something with it in that tiny, tiny window, it just decays and vanishes forever. And this is a perfect way to think about it. Imagine that coffee cup on your desk. Your eyes are registering it all day long, over and over. But unless you consciously pay attention to it, actively think, oh, right, my coffee, that visual input is just gone. Attention is the gatekeeper. It's what decides what gets past that front door. Okay, so let's say you do manage to pay attention to something. Where does it go next? Well, it moves on to what you can think of as your mental desktop. This is your short-term memory, or maybe more accurately, your working memory. Yep, this is your mind's CPU. It's RAM. It's basically where you're conscious right now. When you're solving a puzzle, having a chat, or finally thinking about that coffee cup, you are using your working memory. It's where the real thinking happens. But this is where we hit that famous bottleneck. A psychologist named George Miller figured this out way back in 1956. He called it the magic number. And that number is 7, plus or minus 2. So your working memory can really only hold between 5 and 9 pieces of information at once. This is the exact reason you forget that 10-digit phone number right after you hear it.
So how in the world do we get around this pretty serious limitation? Well, we use a simple but super powerful mental software upgrade. It's called chunking. It's just the trick of grouping separate little items into one big, meaningful chunk.
A phone number is the perfect example of this. Look at that string of 10 random digits. It's 10 separate items. That's too much for your working memory to handle. But the second you chunk it into an area code, a 3-digit prefix, and a 4-digit number, suddenly it's just 3 items. And 3 items, that's easy to hold on to.
All right, but what about the stuff you want to keep for longer than just 30 seconds? For that, you've got to save it to the long-term hard drive. This is your long-term memory.
This is the huge, seemingly bottomless storage warehouse of your mind. It's where you keep absolutely everything, from your best friend's name from first grade to knowing how to ride a bike. Seriously, for all practical purposes, its capacity is unlimited.
And we store different kinds of files in this giant hard drive. You've got your declarative knowledge, which is basically facts, like knowing that Paris is the capital of France. Then there's procedural knowledge, skills, like knowing how to ride a bike without even thinking about it.
And finally, you've got your episodic memory, which is your life story, remembering when you graduated.
Okay, let's put it all together. This little chart is basically the cheat sheet for your entire memory system. Sensory memory is tiny, super brief, and things just decay. Working memory is a bit bigger, but still very short, and you forget because new stuff interferes with the old. But long-term memory, it's infinite and permanent. When you forget something from there, it's not actually gone. It's usually just a retrieval failure. You can't find the path to access it.
So, this is all cool theory, right? But now for the really important part. Now that we understand how the system is supposed to work, how can we actually use that knowledge to learn better? How do we, hack our own memory?
The whole game is about a process called encoding. This is the secret sauce. It's how you move information from that temporary mental desktop into the permanent hard drive. And here's the thing, it's not about repeating something over and over and over. Real effective encoding is all about making meaningful connections between the new stuff and the knowledge you already have stored away.
So how do we actually do that? Well, it all starts with paying attention, right? You got to let the information in the door. Then you have to actively connect it with things you already know in your brain. You're building bridges, not just dropping in random facts. Things like organizing information, using more of your senses, or practicing retrieving it later, all of these things strengthen those connections.
So really, the big takeaway from information processing theory is that it gives us this incredible model. It shows us that, yeah, our brain's hardware might be fixed, but the software we run on it, the strategies we use to learn, that's something we can always upgrade. So, knowing what you know now, what's the first piece of software you're going to install to upgrade your own mental OS?